Hello students, welcome back to my channel. Today I will be discussing about valency. Now this particular video is for those students who have just started learning the basic concepts of chemistry. So without wasting time, let's get started with the video. So what is valency? Valency is the maximum number of electrons that an atom can lose or gain in order to stabilize itself. Now the question is, how an atom stabilizes itself? For this, we have to know about two rules. First is the duplet rule and the next one is the octet rule. Now, first and foremost, we know that in an atom, there are various orbits or shells, right? In my previous video on atom, I have already discussed about the structure of the atom. So if you haven't watched that video, please go and watch that video first so as to understand this topic properly. So there are various shells and orbits, okay? Now, the last shell, suppose this is the last shell of an atom. This last shell is known as the valence shell of that atom. What is the duplet rule? Now, duplet rule, the duplet word means two. According to this rule, an atom will always try to have two electrons in its valence shell. That means it will always try to have two electrons in its last or the outermost shell. And another one is the octet rule. Octet means 8. So according to this rule, an atom will always try to have or acquire 8 electrons in its valence shell or the outermost shell. Okay. So according to the need of the atom, it will either acquire 8 electrons or 2 electrons in its last or the outermost shell. So let's go back to the definition of valency. Now see, valency is the maximum number of electrons that an atom can lose or gain in order to stabilize itself. That means to have 8 or 2 electrons in the outermost shell or the valence shell, an atom will adjust its electron number. It can either lose few electrons to have 8 or 2 electrons in its valence shell, or it can gain few electrons so as to adjust the electron number either to 8 or 2. Clear? So the number of electrons that the atom will lose or gain, that will become the valency of that particular atom. So I think now it's clear. Now let's take an example. This is an atom of potassium. The atomic number of potassium is 19. Okay. Now we know the name of the shells. The first shell that is present in the atom is K, then is L, then is M, then is N, and so on. Okay. Now the atomic number of potassium is 19. In the first shell, that is K, there are 2 electrons because the first shell of an atom can hold maximum of 2 electrons. In the next shell, there are 8 electrons. And in the next shell, there are 8 electrons. The L, the M, the N, all these shells can hold maximum of 8 electrons. Okay? So that's why in the first shell, in the K shell, there are 2 electrons. Then in the L, there are 8 electrons. In the M, there are 8 electrons. And in the N, there is left over 1 electron. Why 1? Because 2 plus 8 is 10. 10 plus 8 is 18. And 18 plus 1 is 19. So 19 is the atomic number. That's why the electronic configuration of potassium is 2881. Okay. There are all total of 4 orbits or 4 shells. Now see. N is the valence shell. Why? Because it is the last shell that is present. It is the outermost shell. And in the outermost shell, only 1 electron is present in the potassium. So, the potassium has to either gain or lose so as to make its electronic configuration ending with 8. That means so as to have 8 or 2 electrons in its valence shell, right? So what will be the easiest way for the potassium to acquire stability? That is to lose 1 electron, because 8 is already present in the M shell, right? So what potassium atom will do, it will lose this particular electron that is present in the N shell, that is the valence shell, in the outermost shell. This particular atom will be lost by the potassium. Then if this particular electron is lost from the valence shell, then the potassium will acquire 8 electrons in the last shell, right? Now then it will become 288. Clear? But when will it lose? When the potassium atom, when this particular atom will combine with some other atom to form compound, then this losing of electron will take place. Okay? So, I am repeating once again. The atomic number of potassium is 19. There are all total 4 valence shells, K, L, M, N. K can hold 2 electrons, L, M hold 8 electrons each, and N there is 1. Why? Because 19, 2 plus 8 is 10, 10 plus 8 is 18, and plus 1 is 19. So in the last shell of potassium, 1 electron is present. So how can potassium atom be stabilized? By losing this particular electron. If this particular electron is lost, then the last shell will have 8 electrons. In this way, the potassium atom will stabilize itself. But this phenomenon will occur when this particular atom will combine with some other atom to form a compound. Clear? Now, as the potassium ion, as this potassium atom is losing 1 electron, as it is losing 1 electron, that's why the valency of potassium is 1. As this atom is losing only 1 electron from its valence shell, so as to stabilize, so as to obey the octet rule, that's why the valency of potassium is 1. Clear? Now see the next example. It is of chlorine. Now, chlorine has atomic number of 17. It has 3 shells altogether, K, L, M. K holds 2, I have already told you. L can hold a maximum of 8. And see, 2 plus 8 is 10. How many electrons are left? 7. 2 plus 8 is 10. 10 plus 7 is 17. So all total 17 electrons are present. In the valence shell, here it is M shell. In the outermost shell, 7 electrons are present. Now, so as to stabilize, so as to attain stability, the chlorine atom will simply gain 1 electron. Why? Because already 7 electrons are present. So, it will be easier for a chlorine atom to gain 1 electron and to become stable, because after gaining this 7 will become 8. Okay. So chlorine atom will, when it will react with another atom to form a compound, then always chlorine atom will gain 1 electron so as to attain the stability, so as to have 8 electrons in its valence shell, so as to obey the octet rule. So as the chlorine atom is gaining 1 electron, that's why the valency of chlorine is 1. Clear? I think now it's clear. Next example is of lithium. Now the atomic number of lithium is 3. There are all total 2 shells present, K and L. In K shell, 2 electrons are present and left over 1 electron is present in L shell. So in the last shell, that is in the valence shell, one electron is present. Okay. So the easiest way to attain stability for lithium atom is to lose this particular electron. So as to lose this particular electron from the valence shell. Okay. So the lithium atom will lose one electron and it will obey duplet rule. Why? Because now it will have two electrons in its valence shell. So when a lithium atom will react with another atom to form a compound, it will always lose one electron so as to attain stability, so as to obey the duplet rule and have two electrons in its valence shell. As it is losing one electron, that's why the valency of lithium is 1. But this time it is obeying duplet rule, not the octet rule. The potassium and chlorine was obeying octet rule, but lithium is obeying the duplet rule. Clear? This is the fundamental concept. Now is the valency. See, we know that there are two types of ions, positive ions and negative ions. Positive ions means those ions which have positive charge. They are known as cations. And negative ions means those have negative charge. They are the anions. Now see, we will see valency of some cations and anions both. Now this table shows those cations having valency 1. Okay. See, potassium, sodium, lithium, hydrogen, ammonium, all these elements have valency 1. And this table shows anions having valency 1. All these elements, chlorine, iodide, bromide, nitrite, aluminate, all other elements are there. You have to remember the formula of these elements. You have to remember the symbol of these elements. Clear? Now see. Apart from that, there are certain elements like copper, silver, mercury, gold. These are the elements who have variable valencies. That means more than one valency. Copper have a valency 1. When it has valency 1, it is called cuprous. When silver has valency 1, it is known as argentus. When mercury has valency 1, it is known as mercurous. When gold has valency 1, it is known as orus. So in this way, these elements have valency of 1. Clear? Now move to those elements who have valency 2. This table shows the cations having valency 2 and this table shows the anions having valency 2. Calcium, magnesium, zinc, barium, nickel, all these elements have valency 2. Again, there are certain elements who have variable valencies. Like in previous case, we saw that copper is having valency 1. In this case, we will see copper has valency 2 and now it is known as cupric. Again, silver valency 2 argentic, mercury having valency 2 mercuric. Okay, in this way there are other elements also you can see in the picture. Now the anions having valency 2, sulfite, sulfate, carbonate, oxide, zincate, peroxide, chromate. You have to, again I'm telling you, have to remember the symbol. Okay, so these are the anions that have valency 2. Next, move on to those elements having valency 3 and valency 4. There are few elements. See, these two are the there are all over 4 elements, cations having valency 3. Aluminium, chromium are there, and ferric and auric. That means iron having valency 3 is ferric, Gold having valency 3 is auric. And there are certain anions like phosphate, nitrite, phosphite. Okay, phosphate is PO4 3 minus, phosphite is PO3 3 minus. You have to be very careful in writing the symbol. Again, there are certain elements having valency 4, like there are certain cations like lead, tin, platinum, manganese. All these have variable valencies, and among them there is a valency of 4, and there is only one anion having valency 4, that is carbide, C4 minus. Okay, you have to remember all these valencies. Clear? Now see, I have taken few examples: copper, iron, mercury. These are the 3 elements. As an example, I will tell you. See, copper is an element which has variable valency. It has 2 valencies, valency 1 and valency 2. Iron also has 2 valencies, valency 2, valency 3. Mercury also has valency 2, that means 2 valencies. One is having 1 and another is having 2. Clear? Now, how you will remember whether we will call it cuprous or cupric, ferrous or ferric, mercurous or mercuric? The simple trick to remember is, suppose there are 1 and 2. An element has 2 valencies, right? One is 1, other one is 2. Now, you will add OUS, us. You will add this particular suffix to that valency, which one will be the smaller one. And you will add Ic, this suffix, to one which will be the greater one. See, if you apply this trick, in case of copper, among 1 and 2, 1 is smaller. So, cuprous, OUS, this suffix is added. 2 is greater. So, cupric, IC, this suffix is added. You can take another example, ferrous and ferric. In case of iron, 2 and 3. Okay, 3 is greater, 2 is smaller. Since 2 is smaller, so ferrous, OUS, is added. And 3 is greater, so ferric, IC, is added. Again, in case of mercury, 1 is smaller than 2, so it's mercurous. And 2 is greater than 1, that's why IC, mercuric, IC suffix is added. Clear? So, whenever in case of variable valencies, in those valencies which will be smaller, we will add us, OUS, and those valency which is greater, we will add IC. Okay, this suffix. So, I think this particular topic is very much clear to you all. And if you think my videos are informative and helpful, then please like my videos and please support me. Please subscribe to my channel and stay tuned to my channel for more such videos. Thank you for watching the video.